Now, for the next example here, okay, take a look in your book on page 304. The problem is actually not going to be on our slide right here, but you can read it in the book, page 304, example, this is 302, that's right, 302, example 4. My two systems are, or the two equations are x plus y equals 7. And then, oops, there you go. Then x plus y equals 5. So first, you're going to subtract the second equation from the first, and then you'll get a false statement. If you take a look at the answers, the answer to the left column, you have x plus y equals 7 and x plus y equals 5. If I multiply by -1 across the second system, it's going to give me zeros for your x's and your y's, and 0 does not equal to 2. Okay, so here it says if a system of equations is inconsistent, the variable terms can be eliminated, and the remaining equation is a false statement. So 0 equals 2. That is not true. Then if it's graphed, we see two parallel lines. They will not intersect. Both lines have the same slope, but different y-intercepts. So therefore, those two lines in example 4 are parallel lines. All right, now we're going to go on to the next page, page 303. This is example 5. So if in example 5 it says solve the system, and you're given two equations right there. So how do we go about solving this system? Well, if you look carefully, it already gives you an x value. X equals -y plus 2. So all I have to do is just plug in -y plus 2 into the 3x, and then I'll have y. So if a system of equations is consistent, dependent, the variable terms can be eliminated, and the remaining equation is a true statement such that you have 6 equals 6. That is definitely a true statement here. So when you graph that, we see coinciding lines. So this is your consistent dependent right in the middle of page 303 on that chart. All right. Example number 5 here says both lines have the same slope and the same y-intercept, and if written in the slope-intercept form, they'll be identical. So example 5 here, we're talking about those two equations, x equals -y plus 2, and then 3x plus 3y equals 6. You can since x is already the isolated solution, then you can plug in -y plus 2 back into your equation for x and then solve for y. Now, so you can see the rest of that solution in your textbook, page 303. All right, now, consistent independent, what does that mean? Consistent independent means that there's one ordered pair solution. The graph is two intersecting lines. The slopes are not equal. And a single ordered pair results from substitution or elimination. And again, these are listed again in your textbook here on page 303. Consistent dependent means that you have all the points on the line are infinite number of solutions. The graph, the lines are coinciding. That means they're on top of each other right there. Then the slopes and the y-intercepts are equal. And a true statement results from substitution or elimination. That means a true statement means that the two statements there, you've got it equals, and you can solve for x and for y. And it results from either using the substitution method or the elimination method. For an inconsistent graph, there is no solution, and the graphs are parallel lines. They'll never meet together. The slopes are equal, and the y-intercepts are unequal. The false statement results from substitution or elimination. All right, now take a look at example 6, okay? Example 6 lists out 3 different equations. There we go. Equation number 1, you've got 3y equals negative 3x plus 9. Your second equation is x plus y equals 4. And then the third equation is negative 6x equals 6y minus 24. Now, I can write each equation in the slope-intercept form. And the slope for equation 1 is negative 1. For the second one is also negative 1. And the third one also negative 1. That's your slope for each of these 3 equations. And then the y-intercept is 3, and then second equation, it has y-intercept of 4, and the third equation has a y-intercept, or the b1 here, also of 4. Equations 2 and 3 describe the same line. That's basically the same line, because the slopes are the same and the intercept are the same. So they are consistent, dependent. They're consistent, they're the same, and they're dependent upon each other. Okay, now equations 1 and 2, I've got the same slope again, negative 1 and negative 1. They're 1 and 2 are then therefore considered parallel lines. They are also inconsistent system. All right, now take a look at equations 1 and 3 here. These also describe parallel lines because the slopes are the same. Parallel lines, so they are consistently, or they are an inconsistent system. Now, I know there was a lot there, a lot of information there. Don't let all that information set you in a panic, okay? Just take it carefully and slowly. You've got all the answers for the steps here in the textbook. So in your lesson, just keep referring back to those examples and the charts. And you have the 3 different types of solutions here. And so our homework for tonight is going to be this whole string of equations here. It looks like it's very long, okay, but it really is not, because the first group of problems really is not. It's just answering multiple choice or matching, identifying basically the equations there. Now, make sure, please, that you show all of your work. Okay, and then for tonight, I want you to try upload this assignment to our assignment page in Teams. Let's see if you guys can try to get used to uploading to Teams instead of emailing the assignment to me. And that way I can see all of your work all together on our class page. Okay, so if you have any questions, remember you can always text me or call me or email me, and I can try to talk you through any questions and answer any questions that you might have. I hope you get inspired by doing some of these problems, and do the best you can, and I will help you as you have the need. Thank you.